Hi there, my name is Pablo Cerro Cañizares and I'm going to talk about this new ideas paper, Automated Engineering of Metamorphic Testing Environments for Domain-Specific Languages. This is the outline that I will follow to complete this talk. First of all, I will give introductional concepts to understand the problem that we're going to alleviate. Next, I will present the proposal of this work, the Goten environment, and finally I will present some conclusions and future work lines. Model-driven engineering promotes models as the main artifacts of the software development process, and these models can be created with general-purpose modeling languages or using dedicated domain-specific languages called as DSLs. Ensuring the correctness of DSLs is crucial for the success of MDE solution, and for this, testing is a widely used technique to check the correctness of proposal. However, specifying test oracle for some DSLs is challenging, and creating test case manually requires a high effort. There is some techniques used for overcome these problems. For example, metamorphic testing is a testing technique in case with this oracle is too expensive to compute or it does not exist. And we think that metamorphic testing may help increase the reliability of these MDE solutions. But however, building these metamorphic environments is costly because of it involves developing tools for defining and executing metamorphic relations, and these relations are independent from each DSL. In order to overcome this problem, we propose an automatic technique for building metamorphic testing environments for DSLs that works at two levels for testing the semantics and testing DSLs programs. Next, I'm going to introduce the proposal. This picture summarizes the proposal of this work. It involves three phases and three roles: metamorphic expert, DSL semantics expert, and tester, who may or not be the same person. In the first phase, the metamorphic expert describes the metamorphic testing environment, and for this purpose, we provide a DSL called Goten, which facilitates the definition of errors, input features that can the metamorphic relation use, output features, and the metadata of DSL execution or simulator environment. The value of this input feature can be extracted from the test model using OCL. Then, in the second phase, the expert of the DSL semantics defines how to invoke the DSL execution and how to extract the value of the output feature using metamorphic relation from the execution results. For example, in the case of the data center DSLs, the expert could map the DSL's model with the input of the Cloud SIEM simulator, and also must specify how to extract the simulator time from the obtained results. Finally, in the third phase, the approach generates the metamorphic environments by using the previous specification, and in this environment, the tester can manually create test models and the environment perform different tasks. Initially, every pair of test model is checked against the precondition of each metamorphic relation. If a pair of models satisfy the precondition, then the precondition of the metamorphic relation is evaluated to determine the success or failure of this test case. At the end of the process, the environment reports the set of pass and fail test cases. The second task is to define new metamorphic relation, and the tester can define new metamorphic relation to complement those predefined in the phase 1. And finally, it is able to generate follow-up test cases. Since the metamorphic relation use input and are specified in OCL, it is possible to create a model finder that can use this OCL constraint to obtain new follow-up test cases of a given source test case. And also, let us mention that both of them satisfy the precondition of an error. Next, the following figure shows an excerpt of the Goten metamodel that consists of 5 parts. The first one is the declaration of the environment, that is the DSL with the domain class, and the metamorphic process with the test model repository class. Next, we must define the input and output features that are defined by these 3 classes. The output features have a name and a type, which must have an integer and long value, boolean or a string, and the input features must declare an OCL definition to calculate the values from input models. Next, we are going to include this OCL definition with an E-class, metadata for define the processors and attributes used in the metamorphic environment, And finally, these metamorphic rules that are used for conduct several expressions, can be binary, for example, and using these different features in order to create new rules. This listing shows a simple Goten program. Lines 1 and 2 shows the declaration of the target DSLs and the test inputs. The inputs and output features are shown in lines 4 to 10. The OCL declaration are shown, for example, in line 6. The metadata of the processor is shown in lines 11 to 14. And finally, the metamorphic relations are shown in line 16. This is the main screen of the Goten environment, that it's an Eclipse plugin developed using EMF for handling the metamodels and Xtext for creating the editor. Level number 1 shows the Goten editor that provides featuring code completion, syntax highlighting, and validation of the feature with each MR. Level number 2 shows the existing Goten projects. Level number 3 shows a project example that implements the method of the processor interface, in this case for execution of data center models using CloudSIM. Level number 4 classifies the test model which is active processor. Level number 5 shows the processor view that's enabled to executing the metamorphic testing process for the selected processor, double clicking on each of them. And finally, the results view, that is labeled on the panel number 6, displays the results of the evaluation. And finally, some conclusions and future work. We have presented Goten, that are the initial steps towards a model-driven engineering solution to automate the construction of metamorphic testing environments for DSLs, and this approach is focused on validating different MDE solutions. As future work lines, we are focused on generating follow-up test cases using model finding, providing different mechanisms to compare the results of different processors, and finally applying the framework to different domains. That's all. Thank you so much. Comments or questions are welcomed.